This is an old Pentium 3 computer. It has a RTL dongle in an PCI card that provides USB 2. The motherboard USB connectors up here, they are only USB 1, so they cannot be used at high bandwidth. This is Windows 7. The sampling speed is 1.7 megahertz, as you can see here. The waterfall is more or less perfect. This is a very strong signal. If I increase it just a little, like this, you can see we get saturation, so it's near saturating signal. The fact that you don't see any glitches in the waterfall means the input is perfectly okay. Now, if I put the mouse here and start to move this window, you can see it works. It doesn't, well, there was something very small, but it doesn't make much of a problem. But it did get 100% CPU load. If I click a signal and try to listen, it will not work well. Do it there. You can hear there are glitches in the output. So I stop the output and exit by X to a waiting state, and then go to the control panel, and here to system. Where do we have that? System is here. Advanced, and again advanced, and then visual effects. This is the default setting in Windows. I click here. That means adjust for optimum performance. Okay. And it's slow. This is just a Pentium 3. And close this. Then I go back here, and in the flinrad window I press B to go back to where we were before. And then listen. The difference is very small. There is another thing I could do, and that is to click here to remove this thing. And flinrad gets upset. So I press X and B, and now run it without the task monitor. And here we go. So 1.7 megahertz is the upper limit for listening. Now the performance is limited, and you can hear there was some glitches again. The parameters I have been setting, I press X and P. 3 kilohertz bandwidth, a sine window, power 1 of sine. The fastest FFT is version 2. And this is an RTL SDR dongle, so I set the amplitude to 50. Then the first mixer bandwidth reduction is 8. It became that by default. The third FFT window power of sine is 2. That's not really necessary. I can make it 1. And here there is a problem, and that is I am not allowed to set 8 really, so I set 7. It's a bug of some kind that I am putting 8 there by default. And then we can listen. And I can make the size of the third FFT smaller here. And the mouse is slow. And it's very marginal. But the waterfall is nice. And it's nice up to about 2 megahertz. Here is the waterfall at 2 megahertz sampling rate on Windows 7. And you can see there are occasional glitches here, but not many. So this waterfall is good enough for surveillance purposes. And the reason for me to show this video on a Pentium 3 is that performance is similar to low-end ARM computers. I believe so, at least. And this shows that it should be possible to use those for interesting tasks with these dongles. You can see the CPU load is steady at 100%. If I put the mouse here and try to move this window, look at what happens. Now I click and then I move. And you see, the mouse moves, but it takes some time before the... And now Windows has to clean up. And it takes quite some time. There are occasional glitches, but not many. And this is a really strong signal. On weak signals, one wouldn't see anything. And of course, I could close the... what is it called? Task monitor or something. And then this would be a little bit better. This is Windows XP at 1.7 megahertz. If I click on the signal, this is the local FM station. You can hear it works nicely. And the CPU load is well below 100%. No problem. This is in SSB mode. FM mode is more demanding, so I will not try to really listen to the signal, but it is here. I can click at something else. If I click on the big signal here, you can see it has some ugly spurs on the side of it. That is because of the poor window. Wrong direction. And now the signal's in the passband. But you can see in the waterfall absolutely no glitches. The CPU load is in the order of 80%, while flinrad is using 69. So I will increase the speed a little bit. Here is Windows XP at 2 MHz. It's an older operating system, so it is more fit for older computers, it seems. So I click somewhere, and you can hear it's only 95%, and there are no glitches. If I increase the baseband bandwidth like this, there is more work to do, and the CPU load goes up, as you can see. I go even wider. This is the maximum bandwidth, and now it's 100%. But still there are no glitches, and there is no problem on the loudspeaker output. I can try to move the task manager like this. I click and move. And you see, there is no time for the task manager, but flinrad is not affected. X on the flinrad screen, X, since the CPU load is high, flinrad doesn't respond very quickly on user commands. So X again, and then W. And here you can see operator skill 3. This allows me to set the timer resolution to 5, which means that the scheduler looks in shorter periods of time. And process priority is 2. That is fairly high. It's not real time, but it's a high priority. That's why moving the task manager doesn't affect flinrad, because flinrad has higher priority here. But priority doesn't help if there isn't enough CPU time for flinrad itself. Now I go to the extreme limit for the RTL dongle. That is U, and then A, and then H. And I set 2.4 MHz. 2, 4, and it's the tuner 0, and sensitivity mode 3, an unknown frequency error. And I'm using the delta 44 for the output. That's because I had to do that in Windows 7, because I couldn't find drive routines for anything else that would fit in the Pentium 3 machine. XX, W, and then D to go back to SSB mode. And I have to change parameters because I have changed the sampling speed. So I set here 3 kHz and 1 for the power of sine, version 2, and amplitude 50. It's just an 8-bit AD converter. Bandwidth reduction as much as possible, that's 7. and only one for this window. And then minimum speed for the output, 8 kilohertz. And that's it. And here we go. Now it's not perfectly okay. You can see the glitches here, occasional glitches. And CPU load, it is 100% steady at 100%. But not really bad if I click on something, the local FM station here. You can hear nothing happens. Here we are. There are many more glitches now. So if I listen to a signal, I can listen to the mirror image here. And you can hear there is a problem. And we got error messages. The AD speed is only 2.03 megahertz. So flinrad cannot do 2.4 megahertz while playing to the loudspeaker. Here are the processing parameters I was using for Windows 7. As you can see, it's the same as I used on XP. So XP is really a bit better than Windows 7 when it comes to system efficiency on old computers. This is Linux Fedora 19 at 2 megahertz. It doesn't work quite well. There are some glitches you can see here, and the CPU load is 100% all the time. If I click somewhere, press the mouse down and you can see there are errors reported of various kinds, and there are errors from ALSA. It doesn't work. flinrad cannot do 2 megahertz under X11 with Fedora. Now, this is a minimum installation of flinrad on Fedora. I close flinrad and go to the command screen down here. Well, I move it to the center and try this. /configure configure what's that? Very odd. Configure with help. And you can see not present libxext, so I didn't use the MIT SHM package for faster graphics. So I will install that and see whether that helps. Copy, paste. Yes. And then I start flinrad again. And after having run configure, I have to compile flinrad again. Make x flinrad. That takes a long time because this is just a Pentium 3. Now, when I start flinrad again, I can press S for the global parameters, S, font scale, let's make it 2. The libraries, oops. After installing the new library, I have to run configure again, otherwise flinrad will not know that the new library is installed. And now the libx.ext is not missing anymore. A lot of things are missing, but I'm just running the RTL SDR now. So make xflinrad. So now we can type xflinrad dot slash xl tab and press S for setup. Font scale 2. The libraries for MIT SHM are installed, so use them, yes. This is the difference from before. And enter N for sizes at percents. I don't remember what I used, but let's say 50% and 70% vertically. Process priority, let's make it 2. Are you sure? Well, high priorities may cause problems, but I'm sure I want that, yes. And no auto start. And then I have to save with W. And it's a good idea to escape and then restart. And here we are with the new fonts and another size of the screen. And I press D. So here we are, 2 megahertz with flinrad under X11 on Fedora. The CPU load here is 100%, nearly. You can read the numbers, it says 100%.0 all the time. But there are no glitches in flinrad, it looks good. I can click on a signal. Let's take the local FM here. I press the mouse and about 2 seconds after that the green line appears. And you can hear there is some typical FM station. Let's look here if there are error messages. No. There are underrun errors, but on this kind of signal I cannot hear it. I can switch off the system monitor, and while it's switching off there is some extra load, but now it's not running anymore and I don't think there will be any more overrun errors. So 2 megahertz, well, there was one. So 2 megahertz is very much near the limit where it is possible to run this dongle under X11. So exit, escape, and I have to have focus on flinrad, of course. Escape. Once again, it's really busy, but now it's closing. And then I can press Ctrl Alt F4, for example, for the fourth terminal. And here I log in. And go to the right place. And then type flinrad /fl tab. Enter. And here we have flinrad with the Frontbuffer device. So that's flinrad, and I press D. And it's the same parameters, it's the same flinrad, but not under X11 anymore. The CPU load is here 69%, and I click the local FM station here, and you hear it. I can move the frequency a little bit. And there are no glitches, and we have a load of 81%. This is 2 megahertz. So we have gained the 20% overhead that X11 brings. After quite some time, we have good statistics, and the CPU load is 78.2%. This is at 2 megahertz sampling speed. I can now show some of the factors that affect the CPU load. XU. Here C, that controls the sizes of the buffers. They are now set at the lowest possible DMA rate. That is 10 Hertz. It means that the buffers have a length corresponding to 0.1 second. So I changed that to 100 instead. Normally there would be a low value and a high value for minimum and maximum, and flinrad would decide, depending on other parameters, what is probably what would fit the user. But now I want to control it more precisely, and I do that by putting the same value for upper and lower limit. X. And I do forget to save because I don't want to keep this. And I go for D. And click on the FM station again. And I have to wait for a while. But not too long. We can see now it is 82.5%. It has gone up from 78. That's 4% having to service the input and output more frequently. I can press T to see what the interrupt rates really became, because they don't become exactly 100 Hertz, they became 61 and 62 Hertz here. There are other things one can do. X and parameters, and the output sampling speed is 8 kHz. Normal today is that sound cards run at 48 kHz, so I press 9 to do that. And then click the FM station here. And now we are up at 85%. So there is a cost for a totally meaningless higher sampling rate, because in CW mode 8 kHz is perfectly adequate. We don't have any signal energy higher than that. So I press escape and restart to get back the original parameters for the DMA. I can press T here, and we will see that there was a problem. This is because of the high sampling rate. Restart and D. And maybe I should wait a little longer for flinrad to calm down before I press this signal. We'll see. No. So when running at a high sampling rate, I cannot have that big buffers. There will be timing problems. Here, flinrad, that's the Frontbuffer version of flinrad, is running at 2.4 MHz on the Pentium 3. There are occasional underrun errors. There was one, but they are not very frequent. This is still 2.4 MHz. I can press T, and you can see 23998, 23999 something. And it's still the Pentium 3, of course. I have a signal generator, an old Hewlett-Packard, and I can knock on it. And you hear it takes about 0.7 seconds. As you can see down here, the time delay through flinrad is 0.7 seconds. Bang. And it varies in frequency as well as in amplitude. I can turn the level up a little bit, and there is the point of saturation. You can see on the S meter that the signal within the passband goes down. So, and I turn down the level. Here we can see that the false signal that come because the first FFT has a so poor window. This is the main signal at 62 on this decibel scale, while the first aliasing spur originating due to that filter is 30 dB below. And on the S meter, the white is the peak amplitude and the yellow is the RMS amplitude. If I make the signal weaker, can see the difference between RMS and peak amplitude goes down. And this is the maximum attenuation I can have on the signal generator. I have to disconnect it. Okay, so I put a reasonable signal level here. And you can see a funny phenomenon, all these false signals. That's because 8-bit is not much. Having the dongle in sensitivity mode at a gain level of 0 means there should be a preamplifier in front. Or in this situation, there should be other signals that would work as dithering. So this is an artifact that doesn't really cause much problems in real life. Okay, about the resampling spurs, they arise because if I click somewhere where the signal on the main spectrum is still fairly strong, I click here, then we have these spurs at a level that corresponds to the level here, and you can see we have them at a separation that corresponds to the FFT1 bandwidth. So we have one here, and one here, and one here. And the level is very low because we are now 70 kilohertz away and on the edges of this this peak in the spectrum. So I can tune the frequency a little bit. That's hard on this old instrument. See if I can get into the passband. It should be quite clear this is not suitable for crowded bands because of the many close-spaced aliasing spurs. They would be suppressed by use of a better window, but then it would not be possible to run at 2.4 megahertz anymore with this dongle. Now I have lowered the frequency, the sampling frequency, to 1.7 megahertz and also applied a better window for the first FFT. This is the sine to power 3 window. There are still spurs caused by inadequacies of the window function. They would go down in level if I would set the bandwidth smaller, but that wouldn't fit the cache of this old processor. But the level is weaker and they disappear at much shorter frequency separations. When I tune the frequency, as you can see here, the first one is 42 dB down. And here's the second one. It's at 106 compared to 60. And I made a mistake. This one is only 20 dB down, this is 40 dB down. And I have to take the big knob, then it's not so easy to turn the frequency anymore. But you can see here they are gone. We are now in the white noise floor. So this is reasonably useful. To have a totally spur-free reception, I would have to bring the frequency down further a bit, but that's not the purpose of this video. It's to give an idea about what can be done on slow computers, and also demonstrating here the stability and nice behavior of the Frontbuffer device. The disadvantage, of course, is you cannot run other programs at the same time. The Frontbuffer is just a screen. And overrun errors? No. But if I start to do things on the screen, for example, I take the mouse and I want to change here, I press the button and scale. Then when I release, you see, flinrad has to recompute something. There isn't time for it, so there is an underrun error. And maybe some glitch a little bit after, before it catches up.